Water is an important part of our everyday life. We use it to drink, eat, shower, and play in, but have you ever thought about a career in water? The Pittsburgh Water Collaboratory is a group at the University of Pittsburgh that studies the water around us. To show this today, we will use a stream table to demonstrate how water moves through the environment. In this video, we will highlight the different ways that water moves in natural landscapes and urban landscapes. Afterward, we will have two collaboratory researchers talk about their research and how their work improves our watersheds. We study watersheds. What does that mean? A watershed is an area of land where all of the rain and snow that falls there drains and flows into a same place. This could be a river, a stream, or a lake. When rain falls in your backyard, it will find its way to a stream or a river. In Pittsburgh, we live in the Ohio River watershed. Everyone lives in a watershed. Even if you don't have a stream in your backyard, the rain will soak into the ground and eventually go to a river through the soil. This process is called infiltration, and it happens in natural watersheds. However, in urban watersheds, it's a little more complicated because of the houses, sidewalks, and roads prevent the water from infiltrating. When you're in the woods, there are lots of trees, plants, and vegetation on the ground that soak up all of the water. It's easy for water to infiltrate. When it rains and snows, all of the water eventually makes its way to the stream. The stream curves through the woods and is an important part of wildlife habitat. The Ohio River used to be a natural watershed like this one, but over time, as more and more people moved to Pittsburgh, we built roads, houses, and bridges that affect the watershed. When you're in a city, watersheds look a little different. Roofs, roads, and parking lots don't infiltrate water, so when it rains, all of the water that falls on these surfaces will run off into the storm drain. This results in more water reaching stream in a shorter amount of time because it can flow faster through pipes than it can through the soil. Sometimes the water travels so fast that it causes floods downstream. Other challenges in urban watersheds are straitened streams, which also make the water flow faster. Sometimes streams are even buried in pipes underground in order to have more room to develop the city on top. In many parts of the city, there could be a stream right under your feet and you wouldn't even know. We study urban streams because they are an important habitat for bugs, fish, and other animals. Urban streams are also important for people. Studying urban streams allows us to understand how to fix problems like flooding, how to keep our water clean, and how to safely develop and build an urban watershed.
Hi, my name is Becky Forgrave, and I'm a PhD student here at the University of Pittsburgh. I study Pittsburgh's 9-mile run and how the stream burial in the headwaters affects the water quality and the flow downstream.
To do this, I installed sensors in the stream that measure how fast the water is moving as well as the water quality. These sensors measure the cloudiness of the water, the temperature, as well as the concentrations of nitrate and dissolved oxygen every 5 minutes. The data from these sensors, which I go out and download, shows me how the inputs from stormwater runoff from different parts of the watershed affect the water quality in the stream throughout a storm event. Also, I can calculate the amount of time it takes for rain falling on the landscape to get to the stream and increase the flow of water. And in urban streams of Pittsburgh, this can be as fast as 15 minutes. Understanding the links between how much it rains and how fast the stream flow increases are important to prevent flooding and protect the stream ecosystem.
Hi, I'm Marja Copeland. I am a PhD student here at the University of Pittsburgh, and I study how urban watersheds are impacted by different kinds of development. So I look at roads, streams, parking lots, and figure out how all of those interact and impact our water quality and the health of our watershed. One of the ways I do this is by measuring culverts. Culverts allow water to pass under structures like roads. Culvert sizes are important because they have to be large enough to allow all the water from the stream to pass through. If the culverts are not large enough, these can lead to flooding and infrastructure damages. Sediments from the watershed can also get trapped upstream of the culverts and deposited on the floodplains. I take sediment cores and use the radioisotopes in these sediment cores to understand how watersheds have changed through time. Studying the history of these watersheds can help us better plan for development in the future.